Glyph sorting, interactive visualization for multidimensional data. Users can select sort keys by clicking on the corresponding glyph component in the control panel. Selected sort keys are then rendered in focus. The populated sort keys are rendered along the corresponding axis. Dragging the visual component off the glyph removes the sort key, bringing the component back into context. In addition, we adopt tooltips to help the users in selecting the appropriate sort key. Ordering the sort keys can be changed by double-clicking on the sort key label in the visualization. Here, we notice the team scores most of their points from lineouts in the attacking third. These are shown clearly by the highlighted glyphs. We develop an interactive, multidimensional glyph plot for viewing sorted results. We next analyze how start position affects the number of phases. We can see that a high number of phases only occur when the team is within opposition territory. The user can brush subsets which renders the glyphs into focus. The rendering order of the selected glyphs can then be sorted. This brings certain glyphs to the front in dense regions. Glyphs in focus are preserved. This allows users to investigate such glyphs under different sort functions. We can observe that tortuosity increases non-linearly to the number of phases. Sorting data with discrete keys can often lead to visual clutter. We introduce hierarchical access binning to relax the positioning of glyphs by enabling additional sort functions to be mapped. New data trends are now visible. In this match, we can see a significant drop in turnover events in the second half compared to the first half. Our sorting method enables users to encode multiple sort keys along a single axis. This enables organization of glyphs beyond one or two attributes, which is essential for analyzing more complex data patterns. Furthermore, this method can be applied to multiple sorting axes. We demonstrate the usability of glyph sorting in rugby event analysis by comparing two rugby matches. Our first sorting strategy investigates the relationship between tortuosity and gain. In match 1, we can see that the glyphs are densely mapped. However, in match 2, we see that the glyphs are a lot more spread out along the x-axis. This means that the average tortuosity here is lower in comparison to match 1. Since a clear relationship is not visible, we investigate a new alternative sorting strategy. In particular, we consider how start event affects the relationship of tortuosity and gain. We provide a user option for displaying averages as additional information to the user. For example, here the blue bands represent the average gain in each start event. A new data trend can be seen in each axis bin, where the position of glyphs follow a top left to bottom right correlation. The same pattern does not appear in match 2. However, one additional observation we can make is that point scoring events occur across all event categories. To understand the trend in details, we enable playback of sorted events. Users can view detail on demand by selecting glyphs of interest. We link the glyphs back to the video, which allows the analyst to gain greater understanding through video analysis. Replaying the events of the selected glyphs in the top left cluster reveals a common strategy used in rugby, whereby the team is kicking the ball out of the fence. This is a pattern which is visually identifiable more easily through glyph sorting.